Hi guys, welcome back. In this video, I want to talk about some special triangles. Although all the triangles out there are special and unique in their own way, but guys, these two are kind of thought of as special triangles in trigonometry courses and in mathematics in general. And what are those two types of triangles? One of them is the triangle which has two angles, 45 and 45, and then the other one is a right angle 90 degrees. And the second one is a 30, 60, 90, where one of them is of course going to be a right angle triangle, and then the other two angles are 30 degree and 60 degree respectively. Okay, so guys, this one where we have 45, 45, 90, obviously this is going to be more like an isosceles triangle, because we know from geometry and basic rules of geometry that equal angles have equal sides opposite to them. So we have to use that fact, and that fact is going to actually, or that rule is going to help us to figure out the ratios for these special triangles, and that's what makes them actually special. So let us first, with this triangle, let us draw this triangle. So it's going to look more like this, like where the length of these two sides, so depending on which we call the angle, so this is 90 degrees of this, so this is my 45, obviously this is also going to be 45. Guys, keep in mind this is not drawn to scale, and I don't have like a ruler or whatever to actually draw it to scale, but I'm going to try my best to make sure that, so this length, this angle, this, if I think of this angle, then this is the side opposite to that angle, and then looking at this angle, this is the side opposite to it. So guys, if these two angles are equal, then obviously these two sides are also going to be equal. It's an isosceles triangle, and that we know this from basic facts from geometry, right? So what does that mean, guys? That means that if I call this length as length A, then this is also going to be A. And if I call these two, if both of them are A and A, then we should be able to figure out the length of the hypotenuse. So to find the length of the hypotenuse, it is going to be h squared is a square plus a square, and h squared is a square plus a square is 2a square, and then if I take the square root on both sides, it's going to be h equals to, well, radical 2 I cannot simplify, so let me break it down. It's radical 2 times radical a square, and then guys, square and square root crosses out. It's simply finally going to be like a radical 2. So that's going to be just a radical 2. So these are the ratios of the sides for a 45, 45, 90 triangle. It's a is to a radical 2. Right? Guys, to make it easier for us to do this simplification or to do the math on this, what we can do is we can divide this by all these three quantities by an a. If I divide all of them by a, then I'll get 1 is to radical 2. And that is the most simplest ratios that we kind of remember or we like to use when we are thinking of the 45, 45, 90 triangle. So the sides are in the ratio 1 is to 1. And guys, it's not too difficult to remember or understand, because we know that the angles, both the angles are the same. So that means the sides opposite to them are supposed to be in the same ratio, or basically supposed to be exactly the same. And then the hypotenuse is just the square radical 2 times the length of each side, which we can see from here as well. So for example, guys, let us try to understand this from looking at an example. So for example, I have a 45, 45, 90 triangle, and one of the sides is, let us say one of the sides is length of one of the sides is one of the side length is, let's say, 4 centimeters. Can we figure out the other two? So guys, if one of the side lengths is 4, then the other one will be exactly the same, 4 centimeters, and the hypotenuse will be just this 4 times radical 2, or you can just simply say 4 radical 2. How do we know that? Because we have already figured this out for any a. If we think of the side length to be a, both the side lengths to be will be same a, and then from there we can see that the hypotenuse is basically the side length times the square root of 2. So based on that information, now we can, like, that makes life easier when we are dealing with 45, 45, 90 triangle. Same thing, guys, if we now know the hypotenuse, let's say we know the hypotenuse for the same 45, 45, 90 triangle. Let us say the hypotenuse is 8 centimeters, and we want to find the lengths of the other two sides. Guys, to find the lengths, let's say L1 or L2, which are basically going to be the same, what we can do here is, so we are going from here back to the lengths of the sides. So to do that, we just have to, so if we are from lengths to the hypotenuse, we are multiplying by radical 2. To go backwards what are we going to do? We're going to do the reverse process of multiplication. What is the reverse process of multiplication? It's just dividing. So we're going to divide this by radical 2. Same thing, divide this by radical 2 because we know they are both the same length, but we don't leave this in a, we don't leave the radical in the denominator, so we got to multiply by radical 2 upstairs and downstairs. We get 8 radical 2 over 2, which we simplify becomes 4 radical 2, and same thing here, we get 4 radical 2. So these are the lengths of the two sides. So that is what is special about the 45, 45, 90, and same thing with 30, 60, 90, and I'm going to show you that in my next video. So one has to kind of just remember the basic things related to a 45, 45, 90 and a 30, 60, 90. And guys, for me personally, it is more about visualizing. So drawing the right triangle and then trying to like remind ourselves or reminding myself that, hey, if the two angles are the same, then the opposite sides to them are also going to be the same lengths. And from there, we can kind of figure out these rules and we can see what is going on. What is the relationship between the lengths of the sides and the hypotenuse, okay? So guys, this is first one, 45, 45, 90. Please take some notes on this and try to play around with some other values for the lengths and the hypotenuse. And then guys, you can always verify, like if these are valid values, what you can do is you can use the Pythagorean theorem, and to verify, you can see that if we square this and square this, add them, take the square root, do I get an 8? From there, you can confirm that these are actually the lengths of the other two sides, okay? So guys, I will see you next time with 30, 60, 90 triangle. Till then, keep practicing. See you next time.